In this video we have the 2019 paper 2 question 12b. Now we looked at question A in the last part, and now we have to do question B. Asks us to calculate the size of the angle ACB. Now if you want to pause the video, or if you want to go back and have a look at the last video, welcome to do so, but I'm going to continue. So we're told that the length of this side so this 50 of BC is 50. Now this would be the radius if this was an entire circle. If we had the full circle going on, then this BC would be the radius. So the radius is 50. So what it's asking is to get the angle. So we don't have to look at DEF anymore, because we know the area of the sector ABC, and we know this radius of 50. So we can just look at ACB. It's much more simple than you think. A lot of pupils thought that you had to use DEF, but for question B this is irrelevant. Again, it's much easier than you think. So now the area of the sector ABC, instead of writing radius, we're going to write BC because we have got two radiuses. So we just want to look at this one, we'll call it BC. I'm going to put RBC so we don't get it mixed up with the other sector. We're going to call this one RBC. And then, so this would be the area of a full circle of radius 50. But we have to multiply it by the angle, and it's the angle ACB is this one. All divided by 360. And this is the fraction of the circle that's the sector. So let's substitute what we know. So we know that the area is 2,750. So we can plug that in. And we know that the RBC, that the radius is 50. So we do pi times 50 squared times angle ACB divided by 360. So what we can do is we want to get ACB on its own. So get angle ABC on its own. We've got this pi and 50 squared. So we can take this over to the other side. So this and this, can move that to this side. It's multiplying on this side, so we divide both sides by 50 squared times pi, and just watch what happens. So if we divide both sides then we cancel this out, take it over. And the last thing we have to do is we have the 360 on the bottom of the fraction. So if we multiply both sides by 360, we then cancel out the 360 on the bottom, and we're left with ACB. I will write ACB on the left hand side. So it's 2750 times 360 divided by pi times 50 squared. Being mindful of bod mass, you want to then plug that into the calculator. And the answer we get is the angle ACB is 126.1. It's to one decimal place. We're going to put 126.1 degrees. It comes up 0.0507 and so on, but to one decimal place we get 126.1. And that's us done. Now let's have a look at how the SQA would give the marks on this question. So the first mark would be for this part, for this line. This line up to that point is the first mark. The second mark would be for this line, and the third mark would be for this line. For the answer, that would be the third mark. It's actually an easy enough question once you realise that you don't need to look at the smaller sector. It becomes so much easier. And a few mistakes people made: if you showed no working, you would get no marks, because this question is an easy question to get the right answer using the wrong method. So to avoid that happening, you have to show exactly what you're doing. As we see, many people in this case, number 1 in the COR, they substituted 30 instead of 50 as the radius. 30 is the radius of DEF, not ABC. So that was the first common mistake. Or the next one is people who accidentally substituted the formula for the arc instead of the sector. Remember, the arc is the distance round the circumference of the proportion of the circle. So, yeah, and the other one, number 6, is a mistake regarding the rearranging of the equation. So, this part down to here, many people cancelled wrong and done the wrong operations, and they put 360 on the bottom instead of on the top. So I hope you found this video useful. Thank you for watching, and best of luck with the studying.